Yeah, good day, guys. This is Mr. Prince Mason Science class, and in this tutorial session, I'm going to be everybody's invited to this tutorial session. I know we are on a public holiday. Happy Louis Real Day to everybody, and like you all know that the Monday session is for students from grade 7 to 9, but everybody's welcomed. If you are able to join and you want to ask questions, you can join. I just stipulated it just to for a particular audience just to reduce the number of people, but anybody can join so that I will be teaching according to how many audience I have on the live stream. So if anybody have any question, you can drop it in the chat box. You can drop it in the chat box. Okay, I'm just waiting for more people to join. I'm just waiting for more people to join. Okay, we're still expecting more people. Still ex- But I'm waiting for you.
I'm not joining.
The live stream is waiting for you.
I'm not joining. Welcome, I'm not joining. Put some of that. Welcome now.
I'm still waiting for more people to join. I'm still waiting for more people to join.
Don't let that thing break. I don't.
Still waiting for more students. Uh, let me let me quickly share my whiteboard. I'm still waiting for more people to join. If anybody gets to the live stream, if you're on the live stream, you can just type something in the chat box and just tell me, hey, hi, this is so and so that I could know who my audience are on the live stream, and so that I can teach whatever the grades of the type of the student on the live stream. Okay. Okay, I think I already see two people on the live stream. Um, let me. Okay now. Today I'm going to be teaching. I'm going to be teaching. I want to pick I'm going to be teaching Pythagoras theorem. Pythagoras theorem. I believe that's a grade 8 topic. So I'm going to pick Pythagoras theorem. So if you are not in grade 7 to 9 and you're on the live stream, let me know what grade you are in, so that I can teach what is more pertaining to your grade. And Pythagoras theorem has to deal with a right angle triangle. It has to do with a right angle triangle like this. So in the right angle triangle, the place facing the right angle is the longest side. That's the hypotenuse. Okay, that's the hypotenuse. And this place, let's say we have this place. The side facing this angle is the opposite. Okay, and the last side is adjacent. The adjacent. And in Pythagoras theorem, we know that the hypotenuse squared is equals to opposite squared plus adjacent squared. Okay. So, for example, if they ask us to prove that 6 plus 8 is equals to 10, we can only prove this by Pythagoras theorem. Okay. So, for example, let me draw a right angle triangle. If I draw a right angle triangle like this, we are looking for this place. This place is 6, this place is 8. Okay. So now we know that hypotenuse squared is equals to opposite square plus adjacent squared. And we are looking for the hypotenuse, right? So that will be hypotenuse, that will be x squared x squared sorry x squared is equals to 6 squared plus 8 squared. Okay, so 6 times 6 is 36. Okay, 8 squared is 8 times 8, that's 64. So x squared is equals to 36 plus 64 is 100. Okay. So we have x is equals to the square root of 100. X is equals to 10. So let's say we are given another one, and we have to prove that 3 plus 4 is equals to 5. Of course, we know that 3 plus 4 is 7. We can also prove this by Pythagoras theorem. So I'm going to do a right angle triangle like this. Okay. So this base is x, this base is 3, this base is 4. Okay, so we have x squared is equals to 3 squared plus 4 squared. Okay. So that will be s squared is equals to 3 times 3 is 9 plus 4 squared. 4 times 4 is 16. So s squared is equals to 9 plus 16 will give us 25. So x is equals to the square root of 25. Okay. So we can say that x is 5. Now let me do something. Let me do something that is just we're not proving, but I'm just going to have a right angle triangle. So we have this side, this side. Let's say we are given the hypotenuse to be 10. Okay. We are given the opposite to be 8, and we are asked to find y. Okay. Since hypotenuse squared is equals to opposite squared plus adjacent squared. Let's say that this is the opposite. So if we have to make opposite squared the subject of the formula, that will be opposite squared is equals to hypotenuse squared minus adjacent squared. Okay. So the opposite squared is y squared. That's y squared is equals to 10 squared minus 8 squared. Okay, 10 squared minus 8 squared. So that will be y squared is equals to 10 squared is 10 times 10, that's 100, minus 8 squared, 8 times 8 is 64. Okay, so that will be y squared is equals to 100 minus 64 is 36. So y will be equals to the square root of 36. Okay, so we can say that y is equals to 6 in this case. Okay, so I'm going to do another one again. Let's say we are that the hypotenuse is 8 and the opposite is 4, and we have to find x, we have to find the adjacent. We know that hypotenuse is equals to opposite square plus adjacent squared. So we want to make adjacent the subject of formula so that we can get x. That will be the adjacent squared is equals to opposites. So sorry, is equals to hypotenuse squared minus opposite squared. Okay. So adjacent is x squared. So the hypotenuse is 8 squared minus 4 squared. So x squared is equals to 8 times 8 is 64 minus 4 times 4 is 16. Okay. So if we do 64 minus 16, let me do 64 minus. So take 1 here, keep 5. 14 minus 6 is 8. 5 minus 1 is 4. So x squared is equals to 48. Okay. But we can write it in a short form. If we want to write it in a short form, we can do 16 times 3. Okay. So we can say that x squared is equals to this. Sorry, we consider s is equals to the square root of 48. Okay. So x will be equals to the square root of 16 times 3. So the square root of 16 is 4 times root 3. So we consider x is equals to 4 root 3. Okay. So I'm going to look for more exercises on Pythagoras theorem. I want to look for more exercises on Pythagoras theorem. Come, I'm just looking for some exercises I can do on Pythagoras theorem. So, for example, let's say we had another one like this. Okay, so we have 5 centimeters. We have 5 centimeters and 8 centimeters. Okay, and we have to find the hypotenuse. So let me just quickly get my calculator. I'll be back in the next 30 seconds. Okay, so we have to find the hypotenuse. Let's say this is A. Okay, so we have that A squared is equals to opposite squared is 5 squared plus 8 squared. Okay, so A squared, 5 times 5 is 25 plus 8 times 8 is 64. Okay, so A squared is equal to 25 plus 64 is 89. So we have A is equals to the square root of 89. So if we do the square root of 89, we get 9 point something, maybe about 9.5. So that's about 9.43. Okay, that's 9.43. So now we have another one, which is like this, a right angle triangle. So this is 6 millimeters and 12 millimeters. Okay, so we have that A square is equals to 6 squared plus 12 squared. Okay, so A squared is equal to 6 times 6 is 36 plus 12 times 12 is 144. Okay, so if we do 144 plus 36, 144 plus 36. Okay, so that 4 plus 6 is 10, right? 0, keep 1. 4 plus 3 is 7 plus 1, 8. So 180. So A squared is equals to 180. So we have to find the square root of 180. So 180, if we do 90 times 2 will give us 180. So 180, 60 times 3 will give us 180. Okay. So I'm trying to look for two. I want to write it in short form. So I'm trying to look for two numbers that I can multiply together, that I'll be able to find the perfect square root of one, and then and I won't be able to find the perfect square root of the other one. So if I'm to do 180, okay, 180 divided by 5, let me see. That's 36. Okay, so A is equals to 36 times 5. Okay, and we know the square root of 36. So the square root of 36 is 6 times root 5. So A is equals to 6 root 5. Okay, so that's it for that question. That's it for that question. I'm going to do another one. We have 10 meters and 7 meters. This one we have 10 meters and 7 meters. Okay, so we say hypotenuse squared is equals to opposite square plus adjacent squared, right? So the hypotenuse squared is equals to 7 squared plus 10 squared. Okay, so we have that the hypotenuse squared is equal to 7 times 7 is 49 plus 10 times 10 is 10, right? It's 100, sorry. So that will be the hypotenuse squared is equals to 149. So if we do hypotenuse is equals to the square root of 149, we'll find the square root of 149. 149. So we should get 12.2. Okay. So I'm going to do Pythagoras theorem in a different way now. So now in this case, let me give you another kind of example. So we're asked to determine, sorry, determine the length of the diagonal of the following rectangle. Determine the length of the diagonal of the following rectangle. Okay. So now we have the rectangle like this. So this is 18 centimeters and this is 15 centimeters. So the diagonals of a rectangle is like this. Okay, these are the diagonals of a rectangle. Sorry, the lines are not straight. So these are the diagonals. Okay. So now in this case, now let's we can find the diagonals in two different ways. Because if you look at it, we can draw a triangle out like this. Okay. You can draw a triangle out like that. And then you can draw a triangle out like this too. Okay. So if we draw a triangle like this could be 18. Because if this place is 15 centimeters, this place will be 15 centimeters. This is 18 centimeters, this place will be 18 centimeters. Okay, so we have 18 centimeters here. This place is 15 centimeters. Okay. Sorry, you see that we draw it this way or we draw it this way. Sorry. This way, 15 and 18. Okay. So in this case, we have to find this side here. So that will be hypotenuse squared is equals to 18 squared plus 15 squared. So the hypotenuse squared is equals to 18 times 18 should give us 324 plus 15 times 15 should give us 225. So if we do 324 plus 225, we should get 549. 549. So hypotenuse is equals to the square root of 549. So if we find the square root, that should be 23.43. Okay. So I just want to check the chat box if there's anybody in the chat box that has any question. Okay. Okay. So I'm going to go back now.